product rule with composite function because you don't know how to factorize. So we look at how to do factorization. Okay, do factorization. Okay, right. So let me ask you a few questions. Let's say a to the power of a to the power of a to the power of 4 a to the power of 4 minus a to the power of a to the power of 2. Okay. So if I ask you to factorize this, take out the common factor, do you know how to factorize? Or maybe
A2 times A2 times A2 minus 1.
a to the power of 2, then bracket a to the power of
A2
2, then
minus 1.
minus 1. So when you take out the a square, so it's 1, right? Okay. Let's say we have x y to the power of 3. Ayo. Don't do all this. Let's say I have x y to the power of 3 x y to the power of 2. Okay. How to factorize this?
XY2
X, y,
2
x, y
power
to the
2.
power of 2. X, y to the power of 2. Then
times y plus 1.
y plus 1. This is correct. Okay, this is correct. So now if I have y to the power u x 3 to the power of 4 minus power 4. Then this one is power of 3. What do you get?
X plus 3.
X plus 3 to the power of
1.
x plus 3 to the power 1. X plus 3 is actually A. X plus 3 is actually A. Let's say we have A to the power of 4 minus A to the power of 3. What you get? What do you get? What is the common factor here?
A3
A to the power 3. Then
times A
A,
minus 1.
no, this is correct. The top one exactly the same. How you do it? A to the power of 4, A to the power of 3. What do you have here? X plus 3 is actually A. X plus 3 is actually A. So this is A to the power of 4 minus A to the power of 3.
X plus 3 power of 3
Correct? To the power of 3. Then bracket
times
X. What is left behind?
X plus 3.
Correct. This is your A lah. Huh? X plus 3 then. X plus 3 then what? What is it? You take out all of this one, take out all. A to the power 3. The A to the power 3, you take out already. What is left in place of this? 0?
Okay.
Is it 0? You take out this 0.
1.
Minus. Because here got minus. Because here got minus, here minus. So this minus 1. Then it will be the same. X plus 3 to the power of 3. Then the one is x plus 3 minus 1. So this one is x plus 2. Is this okay?
Okay.
Okay. So we are going to do this 2 times, in the product rule, we are going to do this 2 times. Okay. So we're going to do it 2 times. Okay. Let's say we have this product rule here. 1e. 4, 3. This one, differentiate the pink color, you get 4. Then this brown color, you keep. Then the pink color, don't differentiate really. Just now you differentiate. So you keep the pink color, you differentiate the brown color. When you differentiate the brown color, you bring down the 6, this one. Then the power here, less by 1. So 6 minus 1. Because this is a composite function, you need to differentiate the inside. Differentiate 2x plus 7, you have 2 here. So this thing, already 2 term left, I just copy down this one. 4 bracket, then something to the power 6. 4 bracket, something to the power 6. This one just copy down. Now for the behind there, there are many terms. So the 6 and the 2 become 12. Then the x minus 3, you just copy x minus 3. Then 2x plus 7 to the power of 6 minus 1, 2x plus 7 to the power of 5. So this is how we simplify. But again, there is a common factor between the front here and the behind here. Okay, there's a common factor. The common factor is 2x plus 7 raised to the power of 6, 2x plus 7 raised to the power of 5. So which one is smaller? 6 or 5? The smaller one is 5. So we take out 2x plus 7 to the power of 5. So we take out here. Then the bracket, what is left inside? You take out 5 apples. Now only 1 apple left. Only 1 apple left. Okay, so from 6 apples, you left 1 apple. Just like here. Right? So x to the power of 6, x to the power of 5. So you take out x to the power of 5, you left with, you take out a to the power of 5, you are left with a to the power 1. So this is a to the power 1. Then behind one, you take out this whole thing. You take out this whole thing. Okay, when you take out this whole thing, nothing is left. But nothing is left means there is a 1 there. There's a 1 there. Right? So it's
Not
4x.
the 2x plus 7 power of 5, you move to the front, and then the 4 times 2x plus 7 power of 6, you move inside the bracket inside there.
Don't understand. What are you saying? You can use this one. You can use the pencil and you tell me. You draw there. You can draw there. You draw there and see what you want to tell me. Or you can draw here. But your finger, you use finger, then you cannot draw because the screen is very small. We are using the phone. So
Okay.
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 Then can draw or not?
Yeah.
Can you just draw? What you think it is supposed to be? Or you can type now. There's a typing here. The typing there. Okay. Right. What? Okay. Ah. Okay. So what is it?
The 2x plus 7
Ah,
power of 5, you move to the front there.
5. This one
You
is 5. Correct.
you change the 4 times 2x plus 7 power 6, you change the place with the
2
2x plus 7 power
power
5.
1. Power 1. It's like this. Like this. It's like this. Right? It's like this. This one become 1. You take out the 5. You take out the 5, then you left with 1. You left with 1 here. You take out 5 here. You take out 5, you're left with 1. So this 5 you take out, there is only 1 left. This one, you take out the 5, there's only 1 left. So you take out this 5, you are left with 1. take out the 5, you are left with 1. The rest, I didn't do anything because I just take out the 5 only. Then this one I didn't take out, so it's still inside here. Okay or not? So far, okay?
Oh, yes.
Okay, So, okay, then I clear all. Okay, so when you take out x to the power 5, right, you left with this. Now, between these two terms, there's still a common factor. The common factor is 4. The common factor is 4. This one has a 4 here. This one is actually 4 times 3. Okay? It's actually 4. When you take out the 4, you no more 4 already. You no more 4. When take out the 4, there's actually a 3 there. 3 bracket 4x minus 3. 4x minus 3. Okay? So the 3 multiplied with 4x, 12x. 3 multiplied with negative 9, negative 3, become negative 9. So whatever common factors that you have in this bracket, you have to take out. If you say, I don't want to take out, can or cannot, then you don't want to take out, you just leave it like this. You will still get marks for the differentiation because your differentiation is correct. Then you don't get the marks for the simplification because you don't know how to simplify, right? So you still get some marks, but not the full marks. Okay, right.
Then where's the 1 go?
Sorry?
Where
The
is the
1
1
go?
go?
1 multiplied with anything is still the same one. 1 multiplied with 4x minus 3 is still 4x minus 3. 1 times 12 is still 12. So the 1 there doesn't carry any significance. But if you don't put a 1 there, if I don't put a 1 there, you may think that, why this one take out, there's 0. Actually, this one take out is not 0. If it is 0, then there will be nothing there. When you multiply back, multiply with 0, then everything will 0. There's nothing there. Actually, when you take out, there's always the 1 there. There's always the 1. Here, the 1 is always there. But if I don't write the 1, then you may think that, oh, it's 0. No. If I write the 1 there, when you multiply anything with 1, it won't change the value. So you might as well ignore the 1. Inside your heart, you know there's a 1, but you don't have to write down the 1. Okay? That is what you mean. So when you expand, then you take out the 4, then you cannot take out anything already. So 2x plus 12, 14x. 7 minus 9, negative 2. So, why here different? Oh yeah, they still take out the 2. There's still a common factor here. 14 minus 2, you can take out the 2. 2 multiplied with 4 is 8. This one take out 2, 7. Take out 2, 1. Right? How to take out the 2? You just divide. Divide 14x by 2, 7x. Divide 2 by 2, you get 1. Where is the 2? The 2 is out here. Multiply with the 4, become 8. So, is this okay?
Okay.
Okay. Now, how to say? I have to go through the quotient rule with you. So what we have done here is, number 1, product rule. Number 2, product rule apply to composite function. What is composite function? The bracket
Change it.
then raised to a certain power, whereby you have to differentiate 2 times. That is the composite function. Okay, right. So you know how to factorize. So this one, number 1, you can do already, no? Right? Can do. But the most difficult one is this one, the F. You have 2 composite functions here. This is composite, this is composite. You differentiate the first function, you have to use composite rule. When you differentiate the second function, you have to use the composite rule. But never mind, you try it first. You try first, then if cannot, then I will show you the next lesson. Right? So this one afterwards I will send these questions to you. Now we are going to look at this question number 5. Question number 5 is about quotient rule, right? Quotient rule. What is quotient rule? You use quotient rule. You use quotient rule when there is a line like that, divide. You have 2 functions. One function at the top, another function at the bottom. Now, how to differentiate this type of quotient? Okay, so I will tell you there are 2 sub functions. There are 2 functions there. One at the top, which is pink color. Normally we call this the numerator. Then one function at the bottom there, which is called the denominator. And I color it this time, I think orange color. So we are going to do the same thing. Differentiate 1, keep 1, then differentiate the back one, keep the front one. So we're going to differentiate 2 times. Same as our product rule. The only difference is that is at the top lah. The product rule is at the top. Then the bottom, you have to write down the denominator square. Whatever that is at the bottom there, you square it and put it at the bottom here. Okay, right. So now I proceed. Pink color and orange color. Now the order is important. Whether you differentiate the top first or you differentiate the bottom first, only one is correct. The other one is wrong. So you listen carefully. I differentiate the top, then keep the bottom. Differentiate the top, I get 2. And this bottom here, I keep, don't do anything to it. Then, different from product rule, instead of add, you have to subtract. Okay, subtract. Subtract what? Subtract the, differentiate the bottom. Differentiate the bottom, then keep the top. Differentiate the bottom, you get 3. Keep the pink color, you get 2x plus 3. 2x plus 3. Then divide by the bottom square. Bottom here, you square. Now, again, for the differentiation one, you have to differentiate the top first. You cannot differentiate the bottom first, then keep the top. Cannot. You have to differentiate the top first, then keep the bottom. Okay. The next one will be differentiate the bottom, this one, then keep the top. Okay. And another difference is you have to minus, not add. Then divide by the whole square. After that, you simplify. Multiply in, simplify. Multiply in, simplify. And you simplify the whole thing, you get negative 11. So the bottom remain the same, 3x plus 1 square. So I can tell you many, many times. As long
Mm.
as you are scared, you dare not take the first step to do it, then you cannot learn. You do it, even if it is a mistake also, you just do. Then I will point out to you why it is wrong, then you will know the correct way. But if you just wait there, wait until you know the correct way, you cannot know the correct way. You have to do by trial and error. You have to make mistake, then people tell you the mistake. You make mistake, people tell you the mistake. That's how you learn, right? So you don't wait until I know everything that I learn. Then I start to do, right? So now I want to test you, right? So you see this number 5b, right? You copy down this 5b. You show me how to differentiate the top, keep the bottom. How to differentiate the bottom, keep the top. Just write up. Wrong, never mind, right? You do this one.
Mm.
You call this y. You call this y, then you do dy dx. When you do this one, you say y equals to this. Right? You try, then you show me.
Can go just now the page.
You want to refer, you refer to this. You refer to this example here. Refer to this example. Very good. Very good. Correct. Okay, this is correct. So since you
Mm.
know how to use the quotient rule, then we go on to some more difficult examples, right? More difficult examples. Why I say this is more difficult, because number one, there are numbers in front. Now, these numbers, you shouldn't differentiate because it's multiply, this number, 2 multiply with this, 3 multiply with this. So number one, don't differentiate numbers. You just take it and put it outside like this. Like this. 2 and 3. 2 is from the top, 3 is at the bottom. So these numbers take outside. Now when you take out these numbers, you have this one, x cubed over x plus 5. Right? X
Mm.
cubed over x plus 5. Now when you differentiate, you have to differentiate the top first. Always the top first, cannot use the bottom first. differentiate the top first, become 3x squared. Then the bottom, you just keep. And differentiate the bottom, you have 1. Then the top, you just keep, don't differentiate. Then divide by the bottom square. You see, when you take out the 3 already, you don't put here 3, no. You put here 3, then become 9. And it's wrong. It's wrong. Well, you are differentiating the number. So this number you take out. So when you square, you only square the bracket x plus 5 square. Okay. And the top you can multiply out and simplify. Right? When you multiply out, 3x cubed plus 15x squared minus x cubed. Then it become 3x squared, 15x cubed, 3x cubed, 15x squared. Now, from the top, you can see that there is a common factor. The common factor is x squared. So you take out the x squared, right? X cubed, take out x squared, become x. Number you didn't take out, you just defeat back the 2 there. You take out the x squared, it become 1. 1 multiplied with 15 is still 15. Right? So now you can put back the numbers. Number put back at the top is 2, 2x squared. Number put back at the bottom is 3, 3 bracket square. So you go through this step again, then you see what I want to show you is only this one. Numbers you don't differentiate, you just leave it outside. The differentiation process is the same as the quotient rule. You go through this and see which one you don't understand, you ask me.
Can.
Okay, can. So we go on to the next question. Now the next question is a mixture of quotient rule with composite function. Now once you see the composite function there, don't be afraid. Because when you see the composite function there, it involves the factorization. Now, the factorization part is the part that you are scared now. Huh? Okay. So you differentiate, there are top one function, bottom one function. Top, you have to differentiate the top first. So when you differentiate the top, since the top is a composite function, you have to differentiate it using the composite function way. Bring down the 3, then the power less by 1 becomes 2. Differentiate inside the bracket, it is 1, right? Although the 1, even you write or you don't write, as I say, it doesn't matter, it won't affect the value. But you keep the habit of writing 1 there. Because if you don't keep the habit of writing 1 there, lama-lama you forget and you think that is 0. And you don't even bother to differentiate what is inside the bracket, right? So don't miss out the 1 there, because it reminds you that you have to differentiate what is inside the bracket. Okay, then the orange color, you keep, don't do anything. Second part, you have to minus. Then you keep the orange color, pink color, sorry. Keep the pink color, you differentiate the orange color, you get 2. So, selesai, finish already. But there are common factors there, right? So you have to take out the common factor. This is x plus 1 square. This is x plus 1 cube. So the common factor is the smaller one, the square. So you take out the square. You take out the square. So the square no more already. Take out the square, so there's no more square here. Only the 3, 1, 3, 1, and the What is left behind is this, right? What is left behind? Here, when you take out the square, because this is 3, you know, when you take out the square, you are left with 1 there. You are left with 1 there. So now what to do? Multiply out and simplify. So multiply, this one don't, this one keep there. Then the bottom is square from the earlier part, is the bottom square already. You just copy down this.